Hello students, this is in continuation with the revision of the chapter Statistics and Probability. Let us continue from previous questions. We'll start with question number 10 onwards. Question 10 is the times in seconds taken by 150 athletes to run a 110-meter hurdle race are tabulated below. The number of athletes who completed the race in less than 14.6 seconds is. We need to find out the total number of athletes who have completed the race in less than 14.6 seconds. They are 2 added to 4 added to 5 added to 71. The total is 82. We need to consider less than 14.6. These frequencies to be added, and this verifies option C as the right answer. Question number 11. Consider the following distribution. The frequency of the class 30 to 40 is. Here, whatever the number of students mentioned, it's the cumulative frequency. We need to find out the frequency. For that, look at these marks obtained. They are not given as a class interval. We shall make the class interval to be 0 to 10. More than or equal to 10. More than or equal to 0 refers to the total is more than or equal to 50, means it is till 60. So in the reverse order we shall do it. It is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. The number of students, they are given in terms of a cumulative frequency. To find the frequency, I need to subtract the next cumulative frequency from the previous. I'll get 5 as the frequency for the first class interval. 58 minus 55, 3 is a frequency for the class interval 10 to 20. 55 minus 51, which is 4, is a frequency for the class 20 to 30. 51 minus 48, which is 3, is a frequency for the class interval 30 to 40. Then 48 minus 42 is 6, is a frequency for the class 40 to 50. 42 minus 0, which is 42, is a frequency for the class interval 50 to 60. The question is to find the frequency for the class interval 30 to 40, which is 3, and this verifies option A is the right answer. Question number 12. If an event cannot occur, then its probability is. Whenever the event cannot occur, this type of event is called as an impossible event. Such type of impossible event, the probability of the event for impossible event is always 0. So the option D, which is 0, is the right answer. Question 13. Which of the following cannot be the probability of an event? Look at these options here. It is 1 by 3, 0.1, 3%. This 1 by 3 is a fraction. 0.1 is nothing but 1 upon 10. 3% is nothing but 3 upon 100. 17 by 16 is a number which is greater than 1. Remember, we know that 0 less than or equal to probability of the event less than 1 less than or equal to 1. The probability value must be less than or equal to 1. Here this cannot be possible, so the right answer is option D. Question number 14. An event is very unlikely to happen. Its probability is closest to. When the event is unlikely to happen, means this must be closer to 0. Among these options given here, the closest to 0 is option A. We need to choose the minimum among the options, that is closer to 0. When the event is not happening, it is impossible event and the probability is 0. Here is unlikely to happen, so we have to choose the option which is very close to 0. So the right answer is option A. Question 15. If the probability of an event is P, the probability of its complementary event is 1 minus P. We have learned, we know that the probability of an event plus probability of not an event, E bar, is equal to 1. So if the probability of an event is taken as P, then the probability of not an event will be 1 minus P. So option C is the right answer. Question number 16. The probability expressed as percentage of particular occurrence can never be less than 100, less than 0, greater than 1, anything but a whole number. Here we know that the probability of an event lies between these two numbers 0 and 1. So when it is converted into percentage, it will be between 0 to 0%, less than or equal to probability of an event less than or equal to 100%. So when we convert in terms of percentage, it cannot be negative, first thing. So it cannot be negative, so it's a positive number. Less than 0 is not possible, so option B is the right answer for the question. Question number 17. If probability of A denotes the probability of an event A, then the value lies between 0 and 1. Option C is the right answer. Question 18. A card is selected from a deck of 52 cards. The probability of its being a red face card is. We all know that in a deck of 52 cards, 26 cards are in red color and remaining 26 will be in black color. Here the question is probability of being a red face card. How many face cards are there which is having a red color? So it's 6 out of 52, nothing but 3 upon 26. So 3 upon 26 is the right answer, because the face cards are King, Queen and Jackal. These are the face cards. So there will be 2 kings which are red plus 2 queens which are red plus 2 jackals which are red. So totally 6 cards will be red out of the total 52 cards. Therefore, 3 upon 26 is probability. Question 19. Probability that a non-leap year selected at random will contain 3 Sundays is. Remember, when it is a non-leap year, the number of days will be 365. Number of days in a non-leap year is 365, and the number of weeks will be 365 upon 7, that is 52 1 upon 7. It means that there will be 52 weeks and 1 day is left out. So one day out of these 7 days are to be considered. In that, how many Sundays are there? So that particular day can be one day can be Sunday, it can be Monday, it can be Tuesday, it can be Friday, Wednesday, Thursday, Wednesday, Friday, and also it can be a Saturday. These are the 7 days. Out of that, the probability of the event, which is one Sunday, is 1 upon the total 7. So 1 by 7 is the right answer. In a leap year, 2 out of 7 will be the right answer. This is a non-leap year, so 1 upon 7 is the right answer. Question number 20. When a die is thrown, the probability of getting an odd number is like that. We have to know that when a die is thrown, the possible outcomes or the total outcomes are 1, 2, 3, 4, 5, 6. So 6 outcomes will be there. That's the total number of outcomes. And less than 3. Less than 3, odd number less than 3. Odd number less than 3 will be only 1. So the probability of this particular event is 1 upon 6. So option E is the right answer. Question 21. A card is drawn from a deck of 52 cards. The event E is that card is not an ace of hearts. The number of outcomes favorable to the event is. Here, the favorable event is all cards except ace of hearts, and ace of heart is only 1. So the total minus 1 is 52 minus 1, which is 51. So this verifies option D is a right answer, because there is only 1 ace of hearts. So only this card is left out. So we need not consider this card in 52 cards. So the total number of cards will remain 51. Question number 22. The probability of getting a bad egg in a lot of 400 is 0.035. The number of bad eggs in the lot is. Here, probability of the event of getting bad eggs is 0.035. 0.035 is nothing but the number of bad eggs out of the total number of eggs, and they have given the total number of eggs, so the number of bad eggs n will be 0.035 multiplied to 400. We need to multiply this and we get the product to be 14, so this verifies option B is the right answer. Question number 23. A girl calculates the probability of her winning the first prize in a lottery is 0.08. If 6,000 tickets are sold, how many tickets has she bought? So here we need to find out the number of tickets she has bought. So out of 6,000, probability is 0.08. So we need to find out n, which is 0.08 multiplied to 6,000. This will be 48 followed by 1, 2, 3, 4, 5 zeros, then 2 decimal places. So we get it as 480. So option C is the right answer. Question number 24. One ticket is drawn at random from a bag containing the tickets numbered 1 to 40. The probability that the selected ticket has a number which is a multiple of 5 is. We need to identify the outcomes. Let me mention the multiples of 5 between 1 to 40. They are 5, 10, 15, 20, 25, 30, 35, and 40. So the number of total outcomes is 8. So the probability of the event is 8 upon 40 because the tickets are numbered 1 to 40, so the total number is 40. So the probability is 1 upon 5, and this verifies the first option A is the right answer. Question number 25. Someone is asked to take a number from 1 to 100. The probability that it is a prime is. We need to identify the prime number between 1 to 100. So the possible or favorable outcomes are, here also it is favorable outcome. Favorable outcomes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. These are the favorable outcomes. The number of favorable outcomes, they are, if you count the numbers here, we get it as 25. So the probability of the event is 25 upon 100, which is 1 by 4. And this verifies option C as the right answer. Question number 26. A school has 5 houses A, B, C, D, and E. A class has 23 students, 4 from house A, 8 from house B, 5 from house C, 2 from house D, and the rest from house E. A single student is selected at random to be the class monitor. What is the probability that the student selected is not from A, B, and C is. Here the total number of outcomes will be the total number of students, that's 23. Here, the probability of the event, the favorable outcomes, let me write the number of favorable outcomes. This is not from A, B, and C. That will be the total minus the number of students from A is 4, from B it is 8, from C it is 5, and we get it as 23 minus 17, which is 6. Therefore, the probability of the event is 6 out of 23. So 6 by 23 is the right answer. With this, I'll conclude today's session. We shall discuss the next set of questions in the next session. Thank you.